Hey guys, Kenna here. Today we're going to go ahead and take a look at the types and sources of air pollution. So let's go ahead and jump right in. Essential questions for today. Number one, what are the four main types of air pollution? Number two, how are point and non-point sources of pollution and air pollution similar to those we discussed with water? Number three, what are the four main types of effects of air pollution? And number four, how can you get involved to improve air quality and reduce air pollution? So before we go ahead and start looking at the types or the point source, non-point source, we need to make sure we understand and are talking about the same thing when we mention air pollution. So what is air pollution? Air pollution consists of gases, liquids, or particles in the air that can have a serious effect on human health, wildlife, vegetation, lakes, streams, soils, and visibility. Whether an air pollutant is a problem depends on how much of it there is, how long it stays around, and in some cases, the weather. The Environmental Protection Agency, or EPA, has set national ambient air quality standards for several pollutants in order to protect public health and the environment. These include fine particles, sulfur dioxide, nitrogen oxides, ground level ozone, carbon monoxide, and lead. Air pollutants of concern include ground level ozone. This forms near the Earth's surface when volatile organic compounds, also known as VOCs, from gasoline, solvents, and vegetation react with nitrogen oxide emissions in the presence of sunlight. This is different from the ozone layer in the upper atmosphere, which protects us from the harmful UV radiation. Sulfur and nitrogen. Sulfur and nitrogen compounds are produced by power plants and factories. Additional nitrogen pollution comes from cars and agricultural sources, including crop fertilizer and animal wastes. And particle pollution. Particle pollution comes from wind-blown dust and smoke from burned fossil fuels as well as forests and grassland fires. Also, toxic compounds. Toxic compounds include metals such as mercury and chemicals such as pesticides. Most human-caused mercury in the atmosphere comes from coal-burning power plants. Toxic chemicals come mainly from the production and use of agricultural and consumer products. And then lastly, greenhouse gases. Greenhouse gases contribute to human caused climate change and include carbon dioxide from burning fossil fuels and biomass, methane from livestock operations, black carbon from incomplete combustion, and even ground level ozone. When we look at all of these different types of air pollutants, there are really four main types of air pollution sources that we identify. These are mobile sources, cars, buses, planes, trucks, trains, things that move. Stationary sources such as power plants, oil refineries, industrial facilities, and factories. These are the things that can be traced more easily to a single location. Area sources such as agricultural areas, cities, and wood burning fireplaces. So it's not usually just a single point that it's coming from, but from a collection of areas that combine to produce a particular area impact. And then natural sources such as wind-blown dust, wildfires, volcanoes. Remember that I said that not all air pollution comes from humans. There are some natural sources here. So this gives you a good idea of what those different sources are that we're talking about. Again, natural coming from wildfires, lightning, and volcanoes. We have cities and livestock that produce area pollutants where it's hard to pinpoint it to just one particular thing, but there's a collection of things that as a group definitely produce pollution. We have stationary, such as our power plants, industry, factories, sewage treatment, etc. And then we have those mobile ones like cars, trucks, buses, motorcycles, trains, planes, etc., where you can go ahead and follow the individual moving object. Mobile sources account for over half of all of the air pollution in the United States, and the primary mobile source of air pollution is the automobile. This is according to the Environmental Protection Agency, and stationary sources like power plants emit large amounts of pollution from a single location are known as point sources of pollution. If you remember when we talked about water, we said a point source is where it's really easy to identify where it's coming from, a single site, versus non-point source, which is accumulated from multiple different places. So, area sources are made up from lots of smaller pollution sources that aren't a big deal by themselves, but when considered as a group can be. These are known as non point sources of pollution. Natural sources can sometimes be significant, but do not usually create ongoing air pollution problems like the other sources we can see above. Agriculture is definitely a big factor when we start looking at the impact of air pollution. Animals like cows and sheep release massive amounts of methane through belching and breaking wind. Methane is a colorless gas which is produced in their stomachs when bacteria break down the food that they eat. This is because they're hindgut ruminants. Across the whole world, livestock is the single biggest source of methane released into our atmosphere. And remember, methane is the second most important greenhouse gas, which can cause climate change. Then we start looking at power generation and industry. During the Industrial Revolution, lots of factories were built near large towns and cities. Today, the main industrial hubs tend to be in the countryside away from the cities. They produce nitrogen dioxide, sulfur dioxide as the two main pollutants associated with industrial processes. To generate electricity, fuels such as coal, gas, or oil are burned at power stations. When these fuels are burned, they release nitrous oxide, sulfur dioxide, and particulate matter, as well as greenhouse gases, which can cause climate change. When the Industrial Revolution first started happening, remember the primary source of all of this energy that we utilized was from coal. And it wasn't the cleaner coal. This was coal just dirty and actually changing enough of the surrounding environment that some of your trees, things like willows and white barked trees, started to turn black. And so we see examples like the pepper moth that actually started seeing an evolution in the change of its wing patterns to match the darker wood as opposed to the lighter wood of the trees that had historically been there. So let's take a look at a couple of these different chemical compounds and the impact that they have. The first one is sulfur dioxide. Now, sulfur dioxide is a gas. It is invisible and has a nasty, sharp smell to it. It reacts easily with other substances to form harmful compounds such as sulfuric acid and sulfurous acid and sulfate particles. We'll talk a little bit more about some of these things when we take a look at acid deposition next class. It is released naturally by volcanic activity and is produced as a byproduct of copper extraction and the burning of fossil fuels contaminated with sulfur compounds. About 99% of the sulfur dioxide in the air comes from human sources. Sulfur dioxide affects human health when it is breathed in, irritating airways and causing coughing, wheezing, shortness of breath, and or a tight feeling in the chest. The other big group that we see a lot from human impact is nitrogen oxides. Now, nitrogen oxides are a group of 7 gases and compounds composed primarily of nitrogen and oxygen, sometimes collectively known as the NOx gases. The two most common and hazardous of these oxides of nitrogen are nitric oxide and nitrogen dioxide. Nitrous oxide, commonly called laughing gas, is a greenhouse gas that contributes to global warming. Nitrogen oxide pollution is emitted from vehicle exhaust and the burning of coal, oil, diesel fuel, and natural gas, especially from electric power plants. They are also emitted by cigarettes, gas stoves, kerosene heaters, and wood burning. Nitrogen oxides can create environmental hazards when they react with sunlight and other chemicals to form smog. Nitrogen oxides and sulfur dioxide react with substances in the atmosphere to form acid rain. And again, we will talk more about that when we go over acid deposition next class. Nitrogen dioxide is used to produce rocket fuels and explosives. Nitrous oxide is emitted during agricultural and industrial activities and during combustion of fossil fuels and solid waste. Additionally, it's used as an anesthetic. Similar health effects are seen to sulfur dioxide. Now, some of the natural sources of air pollution are organic compounds from plants, sea salt, suspended soils, and dust. For example, in the Sahara when you get a dust storm. Other natural sources are released during catastrophes such as volcanic eruptions or forest fires. Large amounts of harmful gases and smoke are released, which can increase background pollution levels for years, even in areas far away from the original source. If we think about an explosion like Mount St. Helens ash actually made it entire way around our planet. Okay, so they were able to get all the way around the planet and back again because of the explosion. So that's a major volcanic eruption, and they're not always going to be that big, but you can see how there's definitely a spread of the products that come out of that type of eruption. Okay. Ozone is one of the most common natural air pollutants. Pollution from human generated and natural sources is often created in one place and transported throughout the air. And so, this is one of the reasons why one city's uh, air pollution is not just their own, because it doesn't just sit over that one city, but actually spreads to other places. And as we saw with the example with Mount St. Helens, sometimes with the rest of the globe. And so we have to be careful when we think about air pollution because it's not something that stays in one place. Sometimes chemical reactions in the atmosphere change pollutants before they are deposited. Pollutants in the air can create haze, making it harder to see, and pollutant deposition can have biological effects in terms of the water or the land. We can see it get put down on land and picked up due to runoff, or it can go ahead and damage the land itself, or you can see it in terms of something like seepage. The location and even the time of year, however, can determine which pollution sources are most important to a particular location. If we take a look at this, you can see natural and human generated emissions, whether it's from agriculture or from a power plant or from a wildfire. Okay, these then get put up into the atmosphere. The winds then grab them and take them and transport them as they're going through these different chemical reactions, forming secondary pollutants before they are deposited, either through rain or through settling or whatever source. And that produces a certain amount of haze and can have biological effects on many of our natural resources. When we start looking at these effects on our resources and on ourselves in terms of human health, there are four main types of effects that we look at caused by air pollution. These are visibility, how easy it is to see, ecological, what does that do to the natural ecosystems, human health, and then economic. So, what is the financial impact in terms of what the pollution is going to do and what we need to do to reverse it? Let's start out by taking a look at visibility. So, how is visibility impacted by air pollution? Air pollution can create a white or brown haze that affects how far we can see. It also affects how well we're able to see colors, forms, and textures of what it is what we're looking at. Haze is caused when sunlight encounters tiny little particles in the air, and these particles scatter light into and out of the sight path and absorb some of the light before it reaches our eyes. The more particles are in the air, the more scattering and absorption of light occurs, and we get reduced clarity and color of what we're looking at. Some types of particles scatter more light, especially when we start looking at humid conditions. So, in this picture, you're taking a look at a good visibility day and a not so good visibility day. These are actually pictures taken of the same location from the same position. And you can see the difference in terms of what you're able to actually see. This air pollution has created a haze that affects visibility. And so, let's say you're going on a picnic or you're going for a hike. The views that you have can have their textures softened, colors faded, and actually obscure things that are farther away. And depending on your perspective, maybe it makes for a cool picture, but you're not seeing everything that's there. And so it's definitely affecting visibility. So how does this work? Tiny little particles affect how well you can see by scattering the light into and out of the sight path of the person looking. Okay. When it absorbs some of those light rays, you don't get them back to your eye. When it hits another particle, it gets scattered. Maybe some comes to your eye, some of it doesn't. And then you're not actually seeing everything that's there. And it's a little distorted and fuzzy. So, what exactly does haze look like? Well, on clear days, air pollution doesn't seem to have a big impact. So, weather actually plays a pretty big impact on the amount of haze and the degree to which the haze impacts your viewing. Okay. On hazy days, air pollution can be visible as a plume, layered haze, or uniform haze. So let's take a look at some of these examples of how, you know, haze may look in a particular background. So plumes and layers can mix with the surrounding atmosphere, creating a uniform haze or overall decline in clarity. So plumes are going to be column shaped. They're going to come off a particular point source, such as a smokestack, like you can see in this example here. And plumes are and layered haze are more common during cold winter months when the atmosphere moves a little bit less. So plumes look like this. Oops. And layered haze is confined to a layer of pollutants that creates a contrast between that layer and either the sky or landscape behind it. You typically will see a layered type of haze when we have things like an inversion layer. That's something we actually get here in Eugene when you get that kind of cooler air that's trapped down below. Okay. So layered haze is something like that that you tend to see here as well. You can also get uniform haze. Now, uniform haze occurs most often when warm air causes atmospheric pollutants to become well mixed. And so then you kind of have this, and sometimes we get this in the summer when we have the fires that come through. You'll get this kind of uniform haze where it's not in a layer, it's not coming in a plume, but instead you just kind of have this overall blocking of the traditional view that you would normally see. Okay. So there are your four different types. Again, compare the clear day to that of the plume, that of the layered haze, and that of the more uniform haze. Plume, when you have a point source, okay, where it's coming out of a smokestack or something like that. Layered haze, when you see something like an inversion layer, and then a uniform haze when you have something like the fires that we get sometimes in the summer, and that kind of blows in and it's mixing well because of the nice warm weather, but then you end up in with these kind of hazy looking views. Now, what can you do about it? Because air pollution can travel long distances, the clean air actions that you take at home will actually help all sorts of places. Parks have clean air and clearer views everywhere. If you want to improve air quality, I recommend your actions will have multiple benefits. The actions below will help you save energy and money while reducing waste and reducing air pollution. Biggest thing you can start with, green your ride. Combine trips, carpool, ride your bike, walk, or take public transportation. Observe speed limits, avoid idling, and maintain your vehicle. That means taking it in to get it fixed up so that it doesn't develop big problems, especially with things like the exhaust system or carburetor. Also consider driving a more fuel efficient or hybrid or electric car. This is something I think my family is looking at, and when we do switch cars, I think one of our vehicles will end up becoming an electric car, just for kind of day-to-day use, so that we're having a lower impact in terms of fuel consumption, trying to avoid fossil fuels since much of our electricity here in Oregon comes from hydro, and then to go ahead and look at better air pollution impact. Okay. Reduce your power usage. Okay, in the Northwest, again, we use a lot more hydroelectric, but in other places in the country, there's definitely a lot more coal or oil being utilized to go ahead and produce our electricity. And so using less electricity puts less load on it. And you can switch to things like compact fluorescent lights or LED light bulbs and turn things off when you're not using them. We have a tendency to have a lot of things that kind of run on standby when we start looking at things like Alexa, or if you have, you know, some of these Wi-Fi systems, they don't use a lot, but they just are constantly using electricity. Get comfortable. The best thing that you can do is to insulate your home. And use a thermostat that can allow you to reduce your energy use for heating and cooling. So when you're not there, it turns itself down. Be food smart. Support local agriculture as much as you can, then it's not traveling as far. Try and make minimal inputs. Now, a lot of our fertilizers and things are based on fossil fuels, which are going to go ahead and release more air pollution when they're going to go ahead and be consumed. So make sure that we're not just looking at food miles, but also looking at efficiency in terms of how many inputs we need to go ahead and get the materials we're trying to get to. Okay, understand the impact of your food choices. Waste less food. I know they're old adages, but reduce, reuse, recycle. Takes energy to sell products that we use. The more we use it, the less we're going to go ahead and have to make more, which uses more energy and puts more fossil fuels into the environment. Refill and reuse your travel mugs and water bottles instead of buying bottled water. That's also a benefit when we start looking at water, right? It takes a lot of water indirectly. Okay, that's that virtual water to go ahead and produce tons of the goods and services that we consume. And if you learn something here or learn something somewhere else, share your story with your friends. Okay. They're more likely to listen to you than they are to some of the scientists and experts who know the most about this. So if you feel strongly about this and want something to change, you be the one that's going to go ahead and tell your friends, hey, look how cool this is. Look at the impact we can make. And then one becomes two, two becomes four, four becomes 16, and so on and so forth. And all of a sudden, you've got a grassroots effort of people trying to make a change. Okay, guys, that's what I've got for you. Stay healthy, stay safe, and I'll talk to you soon. Take care. Bye bye.